Hi guys, in this video we're going to talk about why we have the unit circle and how we can use it to determine trig ratios for a lot of different special angles um, in our trigonometry. So let's start by looking at the first quadrant, which was the easiest. So in our previous video we talked about where these coordinates come from. They come from our special triangles, and so I'm just going to fill in really quickly the coordinates, the x and y coordinates of these special points around the circle. So this one was the square root of 3 over 2, 1/2. This one was the square root of 2 over 2, and another square root of 2 over 2. And this one was 1/2 square root of 3 over 2. And this one was 0, 1. Okay? Now, each of these coordinates corresponds to a specific angle of rotation that we have gone around this unit circle. So this first one is when my unit hypotenuse here, 1 unit long, has rotated positively, right? Remember, rotation in the coordinate system positively is counterclockwise. So if we rotate 30 degrees, that's where this coordinate would be. And so what this helps us do is if I quickly want to remember what is the sine of 30 degrees, if I have my unit circle, I can look at the 30-degree mark. And if I remember that sine is the opposite side, that's the y-coordinate. That's the height of 30 degrees. And so what we're going to find out is that all of our y-coordinates represent our sine ratios. So it's just something you got to memorize. Sine represents y. Okay. For cosine, those are going to be our x-coordinates. So x-coordinates are always going to be cosine. So if I wanted to quickly figure out what the cosine of 30 degrees is, I would look at the x-coordinate here, and that's equal to the square root of 3 over 2. Okay? It's the same process for 45 degrees. It's the same for 60, in that we just use their coordinates here to figure out that this is the cosine ratio of 60 and this is the sine ratio for 60. Okay? Now, on your unit circle, we'll typically have two ways of representing angles, because in a previous lesson we learned that we don't just have degrees, we can also describe angles in radians. So if we were to convert these into radians, 30 degrees is the same as pi over 6. Okay? Remember that a full 360 is equal to 2 pi. And half of a circle, 180, is equal to 1 pi. So if we use this conversion on 30, we would get pi over 6. So we would say, just a reminder, 30 degrees times 1 pi radian for every 180 degrees. When you multiply, you just multiply straight across. So this would be 30 pi over 180. 30 over 180 reduces to pi over 6. Okay? So pi over 6, for the 45-degree angle, this one would convert to pi over 4. And for 60 degrees, this would convert to pi over 3. Once you've constructed this a couple times, you'll start to memorize all of the radians with their corresponding special angles. They all reduce very nicely with 180. And then for here, this is our first quadrantal. This is a 90-degree angle. That would be pi over 2 for our radians. Okay, so this is the full construction of a unit circle. It gives us the angles in both radians and degrees, and it gives us the sine and the cosine and sine ratios for either of those angles. That's the purpose of the unit circle, is it allows us to quickly find ratios for specific angles around the circle. So let's look at continuing this pattern from the first quadrant into all of the quadrants. So we're going to skip ahead. You can copy that down into your first quadrant here. We're going to go into this quadrant. This coordinate is the reflection of our first quadrant here, so that would be negative 1/2 square root of 3 over 2. This would be negative square root of 2 over 2, square root of 2 over 2. And this one would be negative square root of 3 over 2, positive 1/2. Now, if we're looking at our angles, right, and we want to figure out what they are, remember that the triangles that we're creating come from the center origin, and need to be lined up on the x-axis. So a lot of times students will try to imagine the angles right here. That's not correct. All of our angle placements should come from the x-axis. Now, some of you might be saying, shouldn't we be starting from the positive x-axis like I mentioned before, that all of our angles start from there? And that is correct. So if we're starting from this positive x-axis and rotating clockwise, we can find the angle that this ray represents, this hypotenuse. Okay, now what it's going to correspond to is the angle on this side. So let me give you, for instance, if this is the ratio for a 60-degree triangle, I can imagine the 60-degree triangle being formed right here. So this would be 60 degrees. But really the angle goes from 0 to this point. Well, how do I figure that out? Well, you take 180, which is the full rotation to a flat line, and you subtract 60 from it. So this is the ratio for 120 degrees of rotation. That corresponds to 60 degrees. Okay? So mathematically what we're doing is we're saying, okay, if this is my 60-degree angle, I'm subtracting it from 180 to get that it's really 120 degrees of rotation from the x-axis. So this angle of rotation here is 120. And we can continue that, that pattern to our other two angles right here. So if this is 120 degrees, this should correspond to 45. So if I do 180 minus 45, I get 135 degrees for this angle. And then this triangle right here, this is 30 degrees. So I do 180 minus 30, and I can get my second quadrant angle as 150 degrees. Okay, so I'm going to clean this up a bit because it gets a little messy if we leave all of our notes in there. So that's how we're figuring out these angles, right? This corresponds to the 60-degree angle, so I just subtract it from 180 to go backwards and figure out what it is starting from the positive x-axis. Same thing with 45, same thing with 30. Once we've gotten all the way around to the other side, this is 180 degrees of rotation. And now we would continue that pattern, but this time we're just going to add on to 80 degrees. So my triangles are now just being tacked on to 180. So here's my 30-degree triangle, right? Here's my 30-degree angle, plus 180, that's 210. From 180, if I go 45 degrees, that's going to be 225. If I go 60 degrees, that's 240. Okay, the third quadrant's a little bit easier because you don't have to subtract, you just keep adding on to 180. And then once we get all the way around here, we add another 30 degrees to get down to 270. We're going to repeat the process. We're going to add 30, add 45, add 60. So this is 300, 315, and 330. Until we get all the way around, this is, you'll notice there are two lines here. That's because this is both 360 and 0 degrees, whichever way you want to think about it. Okay, once you have these angles in, all you have to do is convert them into radians. Just a reminder how to convert to radians. You take 120 degrees, we'll do this one, multiply it times pi, and divide it by 180. So really, I'm going to reduce the fraction 120 pi over 180, 120 over 18. I can divide both of these by 6, so this is 2 pi over 3. Okay, and then fill that in for your radians, because you'll start seeing problems both in degrees and radians, and it's helpful to have all the radians listed as well. This one would be 3 pi over 4, and this one would be 5 pi over 6. Okay. 180 is a full pi. Now, one way to help you with your radians is if you think them as slices of pie, right? So if I understand that 30 degrees is a sixth of the pie, right? It's 1/6 of pi. Every 30 degrees, I get another sixth. So this is 1/6, 2/6, 3/6, 4/6, 5/6. Okay. Now a lot of those sixths reduce, but we can write it first that way if you want, and fill them all in, and then reduce them. So one way to help remember it is that if I know that this is 1/6 of pi, and I go another 30 degrees, this is 2/6 of pi. This is 3/6 at the 90 here. 3/6 of pi. 3/6 reduces to 1/2 though, so we won't leave it that way. We'll need to reduce it. Same thing with 2 pi over 6. That reduces to 1 pi over 3, like we showed before. Okay, so we're doing that pattern, but we're doing it all the way around the circle. So if I do another 6th here, that would be 7 pi over 6. Right, this is 6 pi over 6, 7 pi over 6, 8 pi over 6. That reduces to 4 pi over 3. And this would be 3 pi over 2, because that would be 9 pi over 6. This is 10 pi over 6, which reduces to 5 pi over 3. And then this is 11 pi over 6. That one does not reduce. And then all you have to do is fill in your 45s. This is 5 pi over 4 and 7 pi over 4. Okay. If you need to write out the conversion each time, that's not a problem. Take the time to do that until you become really comfortable with these fractions. Okay. Once you've got your coordinates from our previous lesson, you can pop those in down below, and now you have a really easy system for evaluating any trig ratio for a special angle. All right, but let's watch and see how the negatives affect it. So a lot of these are going to be repeated values, but with negatives. So for an example real quick, let's just practice taking the sine of 5 pi over 6. If I was to give you this problem, and I said use the unit circle to evaluate sine of 5 pi over 6, you would first locate that radian. 5 pi over 6 corresponds to 150, so that's this angle. So I'm going to use this coordinate. So your answer will either be negative square root of 3 over 2 or 1/2. Look at the trig ratio to determine which of the two coordinates you should use. For sine, which coordinates do we use for sine? If you look back up above, we said that sine is always represented by y coordinates. You have to memorize that. So for these two coordinates, I'm going to use the y coordinate of 1/2. That's the ratio for the sine of 5 pi over 6. Okay. If we tried the cosine of 120, 120 is right here. For cosine, I use the x-coordinate. And look, this x-coordinate is negative in the second quadrant. So my answer will be a negative ratio of negative 1/2. Okay? So that's how you can get negative ratios from your trig functions around the unit circle. If you're ever in the second, third, or fourth quadrant, you have a possibility of having a negative ratio. Okay? This pretty much wraps up understanding the unit circle. Make sure you fill out your own. Double check that it's filled out correctly, and use it, because it's going to be super helpful in this course and in next year in pre-calc. Okay? Have a great day, everyone.